And sirs, it's my privilege to introduce Dr. Alison Li, again showing the influence of Michael Bliss. She was his PhD student, and she has written the definitive book on James Bertram Collip. And she has also been responsible, along with Chris, in terms of the honor that took place in Belleville, Ontario, about 120 miles east of Toronto. We don't have that at the University of Toronto, but we have it in Belleville. So it's one of those anachronisms that occur. But Alison has also written a recent book called Wondrous Transformation. She was brave enough to write a book about Harry Benjamin, who was a European but largely a New York physician, who got into the various transgender issues very early on, including before the First World War and then, until it became more fashionable as endocrinology developed and when it understood hormones such as estrogen and progesterone and so on. So her book that just came out recently, Wondrous Transformations, is written with a cool style, very well written, but not with a political bias, which many in today's society might leap at. No. So it's my pleasure to introduce her, and she's going to talk about, let me just get the right title, Wondrous Powers, Collip's Contributions to the Development of Insulin. Please welcome Alison Li.
Thank you so much, John and John. Late one night, the frigid winter of 1922, James Bertram Collip was doing what he loved best, working alone in the lab in the quiet, still hours. His wife and young daughters were all down with the flu, so Bert Collip was relegated to sleeping on a cot in the lab at the University of Toronto. That night, Collip washed a mash of cow pancreas in increasingly concentrated solutions of alcohol. His goal, to free an elusive principle from the fats and proteins with which it was bound. With each wash of alcohol, more and more impurities were pulled out of the solution. Sometime around midnight, Collip increased the concentration of alcohol to above 90%. At that moment, a precipitate came out of solution. As a colleague later put it, Collip then saw insulin. Collip ran down the hall to telephone his wife. Honored guests, ladies and gentlemen, it is a great privilege for me to join you on this wonderful occasion here in Aberdeen, the home of J.J.R. MacLeod, to pay tribute to the 4 co-discoverers of insulin. And it's my special pleasure to tell you about the contributions of James Bertram Collip. Collip received many honorary degrees and awards in his lifetime, but he, like MacLeod, never became a household name like Banting and Best have. I'm grateful that through this event and others like it, we are beginning to change that narrative. So let's remember, in 1921, diabetes was relatively rare, but when it was diagnosed in childhood, it was rapidly and inevitably fatal. Those diagnosed in childhood could expect to live only 2 or 3 years at best. A leading hypothesis at the time was that diabetes was due to a problem in the patient's pancreas. And so the thought was that if an extract could be made from the pancreas of an animal, it might be used to treat diabetes in human beings. There had been an estimated 400 attempts to make such an extract, but none of them had been pure enough that they could be safely given to human beings. As my colleagues have already told you before our break, Frederick Grant Banting conceived what he thought was a novel approach to making an extract to relieve diabetes. And driven by this idea, he persuaded Professor John James Rickard MacLeod, who I should actually have called, not yet Regis, when he was still Professor MacLeod, to provide the facilities and resources to let him test this hypothesis. So in May 1921, Banting began his experiments, guided by MacLeod and assisted by Charles Herbert Best. And by August of that year, Banting and Best has succeeded in making an extract that lowered the blood sugar in depancreatized dogs, that is, dogs that had been made artificially diabetic. And for these young researchers, this was an important accomplishment. But in truth, several other researchers had already done as much years before, and some of the most notable were Georg Sulzer, Ernest Lyman Scott, Israel Kleiner, and Nicolae Polescu. That is, Banting and Best had not done anything that had not already been accomplished and published by other researchers. All of these had made pancreatic extracts that had affected diabetic symptoms in experimental animals and in some cases in human beings as well. All of these extracts, however, contained impurities that caused harmful side effects such as fevers, chills, and abscesses at the site of injection. What no one had been able to accomplish, what remained the holy grail, was to make an extract that could be used safely and continuously to treat a person with diabetes. So what the team needed now was a good biochemist. Enter James Bertram Collip. Collip was a graduate of the University of Toronto. He received his PhD in 1916 and was assistant professor of biochemistry and physiology at the University of Alberta in Edmonton. In 1921, he was awarded a Rockefeller Traveling Fellowship, and so he and his young family arrived in Toronto that year to begin their year of leave. Sometime that spring, Collip and Banting met in MacLeod's office, and Collip expressed interest in their project and offered his help. After the promising results of that autumn, Banting asked MacLeod to invite Collip to join their work, and Collip agreed to do so. He started in earnest around December 12th. What happened over the following 6 weeks would be remarkable. At the age of 29, Collip was already a seasoned experimentalist, so he was able to set to work quickly and systematically, and he soon found ways to speed up the research. One of the helpful things that he learned right away was that he could test the strength of the extract on normal rabbits, rather than having to create depancreatized dogs, as Banting and Best had done. And this meant he had a much less expensive and more readily available assay for his extract samples. He also adopted a new method of blood glucose analysis that allowed for quick, convenient measurements with just a small volume of blood. In rapid succession, Collip made several crucial discoveries. First, he proved that the pancreatic extract reduced ketones in the urine. And second, he showed that it allowed the body to convert glucose into glycogen in the liver. So why were these findings important? We know that Banting and Best had demonstrated that their extract caused a drop in blood sugar. But this in itself was not conclusive, because blood sugar can be affected by other factors, such as shock or the presence of foreign proteins. Collip's data gave definitive proof that the extract actually restored the ability of the diabetic body to metabolize sugar. So we see here that Banting, a physician, was really focused on finding a treatment for diabetes. But Collip and MacLeod, the research scientists, the physiologists and biochemists, understood what they were doing in broader scientific terms. They were not just trying to purify an extract, they were also trying to clarify its chemical nature and to understand its role in the physiological function of the body. Over the next weeks, as Collip's work progressed, his extract became more and more potent. He noticed that his test rats became so hungry that they began to eat wood shavings. And one day, a rabbit actually went into convulsions. Collip's first thought was that the extract must be toxic, and indeed, previous researchers had seen this reaction and had assumed the same thing. But suddenly, Collip had an idea. Maybe it was not that the extract was not pure enough. Maybe it was actually too pure. He quickly took a blood sample from the rabbit and set it aside, and then he injected the animal with a sugar solution. The rabbit recovered. Collip then tested the blood sample that he had previously set aside, and he found that there indeed was almost no glucose in it. Collip had discovered the hypoglycemic reaction. A colleague who was in the lab at the time later said, "It all looks simple now, but it was the most thinking per square meter per minute that I have seen." This finding would later serve as an important warning to physicians and patients of the potentially fatal consequences of insulin overdose. For Collip himself, this month felt incredible. In early January, he wrote to the president of the University of Alberta saying, "The crucial experiment was tried out just before Christmas break, and the results were so striking that even the most skeptical would be convinced. I have never had such an absolutely satisfactory experience before, going in a logical way from point to point into an unexplored field, building absolutely solid structure all the way. We have attained a mysterious something which, when injected into totally diabetic dogs, completely removes all the cardinal symptoms of the disease. At the moment, it is my problem to isolate in a form suitable for human administration the principle which has such wondrous powers, the existence of which many have suspected, but no one has hitherto proved. To be associated with the solution of a problem which for years has resisted all efforts was something I had never anticipated." But tensions among the group were growing, as we have heard. Banting insisted that they do a clinical trial using a version of the extract that he and Best had made. So on January 11th, Leonard Thompson, a 13-year-old boy with diabetes, received an injection of Banting and Best's extracts. The results were disappointing. No clinical benefit was observed, and what's more, painful abscesses formed at the site of injection. Years later, Banting would acknowledge that their results that day had not even been as good as those of Zurzer in 1908. In the days that followed, Collip threw himself into the purification problem, following standard biochemical procedures to mash, wash, filter, and centrifuge the extract. And then, on the night of January 19th, he found a way to trap the antidiabetic substance in a semi-pure form. Collip wrote a few days later, "The problem seemed almost hopeless, so you can imagine my delight when about midnight one day last week, I discovered a way to get the active principle free from all the muck with which it appeared to be inseparably bound." 4 days later, on January 23rd, his extract was tested on Leonard Thompson, this time with dramatically different results. There were marked improvements in blood sugar and urinary sugar and ketones. The boy felt stronger, brighter, and more active. This was the first unambiguously successful clinical use of a pancreatic extract on a person with diabetes. In 6 short weeks, Collip had accomplished what had eluded other researchers for decades. Collip's achievement was a key breakthrough for the Toronto group. When Banting and MacLeod were awarded the Nobel Prize in 1923, as we have heard, Banting immediately announced that he would share his prize money with Best, and MacLeod followed suit by sharing his with Collip to indicate that he felt Collip's role had been equal to that of the others. But as the years went by, the discovery grew increasingly associated with Banting and Best alone. Collip, who left Toronto shortly after this, and MacLeod, who returned to Scotland in 1928, were left out of the story. In 1982, as we've heard, Michael Bliss's definitive history of the discovery decisively changed the narrative because of his compelling argument that insulin was the result of the teamwork of Banting, Best, Collip, and MacLeod. And in decades since, this interpretation has become widely accepted. And in later years, Bliss argued that Collip's purification of the extract was the single most important step in bringing the whole enterprise to a successful conclusion. And he said he regretted he had not been even more explicit in arguing that Collip probably should have been included in the award of the Nobel Prize. Bert Collip went on to become one of the most eminent figures in Canadian medical research. He was always famous for his restless nature and the speed with which he thought, spoke, and made decisions. He loved spending long hours at his still, brewing extracts from large vats of glands, rushing back and forth, adjusting this or that mixture, all the while smoking large, hand-rolled cigarettes. And in doing this, he isolated many more important hormones, including parathyroid hormone and several pituitary and ovarian hormones. At McGill University, he headed a thriving team that flourished in an atmosphere of enthusiasm and productivity, and which generated a large body of work of international significance. During these years, on a trip to the UK, Collip was a guest at MacLeod's new home here in Aberdeen. And once the heated emotions of the insulin days were past, Collip and Banting reconciled. Collip would be the last friend to see Banting before Banting's tragic death in a plane crash in 1941. Collip, along with Best, became the elder statesman of Canadian medical research. Collip played a key role in shaping the federal funding of medical research through the war years and afterwards through the National Research Council of Canada, and he ended his career as Dean of Medicine at the University of Western Ontario. In later years, Collip would always modestly say that about the insulin days that he had only done what any good biochemist would have done, and there's certainly a lot of truth in that. What is even more to the point is that he always recognized that the endeavor had been a collaborative one. Collip was a good biochemist, but at Toronto, under the leadership of J.J.R. MacLeod, he had the right tools, the right resources, and the right collaborators. A comparison with the discovery of penicillin is instructive. You will probably remember that Alexander Fleming discovered the bacteria-killing effects of the secretion of a particular strain of mold in 1928, but his discovery lay unpacked for more than a decade. It took the work of Howard Florey, Ernest Chain, and their colleagues at Oxford to turn an interesting observation into a therapeutic agent, and the combined efforts of hundreds of workers at several pharmaceutical companies under the emergency conditions of World War II to solve the problems of mass manufacture. In contrast, the insulin collaborators were able to get their life-saving product into the hands of doctors and patients in many countries around the world in just over 1 year. A breathtakingly short time. It is this remarkable achievement, one that has saved the lives of hundreds of millions of people with diabetes, that we celebrate today. In later years, when a philanthropist, a woman who, like many of you, owed her life to insulin, wanted to celebrate Collip's contribution by donating a plaque, he asked her to change the proposed wording from recognizing him for the discovery of insulin to the development of insulin therapy for diabetes. Collip explained, "Although I have been guilty of using the word discovery on occasion myself, I generally do not like it. Most so-called discoveries represent simply the last but important step in a long series of previous steps, representing contributions of many others through the years in the scientist's search for truth." So today, as we celebrate Collip's contribution as one of the Toronto Four, let us remember his hard work, his quiet humility, his thrill in scientific exploration, and most of all, his deep sense that he was taking part in a collective enterprise. Thank you.